To calculate the volt-ampere load for multiple electric ranges, there are different approaches depending on the power rating and quantity of the ranges. If you have two ranges that each exceed 27 kilowatts, you treat them as one range for calculation purposes. This consideration stems from electrical code definitions where a range is an appliance for cooking or heating food with a surface area exceeding 1.5 square feet, which is about 1.4 square meters. For example, consider two ranges each rated at 19.2 kilowatts. The calculated volt-ampere load would be determined by multiplying the total kilowatt value of both ranges by a factor of 1.15. In this case, the calculation would be 2 times 19.2 kilowatts, which equals 38.4 kilowatts, then multiplied by 1.15, resulting in 44.16 kilovolt amperes. Now, if you have three ranges and each range is rated at 13 kilowatts, the approach is different. You would calculate the volt-ampere load for each range individually and then sum the results to find the total volt-ampere load. For the first range, the calculation would be 1 times 13 kilowatts multiplied by 1.15, which equals 14.95 kilovolt amperes. Since the other two ranges have the same power rating, their volt-ampere load would also be 14.95 kilovolt amperes each. The total calculated volt-ampere load would be the sum of these individual loads, which is 14.95 kilovolt amperes plus 14.95 kilovolt amperes plus 14.95 kilovolt amperes, which is 44.85 kilovolt amperes. To summarize, firstly, if you have two ranges and they both exceed 27 kilowatts, they are treated as a single entity for the calculation. Secondly, if you have multiple ranges where each range has its own designated kilowatt rating, you calculate each range individually and then add the result. Here are some additional considerations. The factor of 1.15 that we have used assumes that the ranges are operating at a standard load factor. The load factor can vary depending on the usage and the type of cooking being performed. In some cases, a higher load factor might be applicable depending on specific application and code requirements. Always refer to the latest edition of the relevant electrical code, such as the National Electrical Code (NEC), to ensure compliance with local regulations and standards. These codes provide tables and guidelines for calculating the demand load for various appliances, including electric ranges. If you are working with a large number of ranges, it is important to consider the diversity factor. The diversity factor takes into account that not all ranges will be operating at their maximum load simultaneously. This factor can reduce the overall demand load on the electrical system. The calculations we discussed assume that the voltage supplied to the ranges is within the standard voltage range. If the voltage is significantly different, it can impact the current drawn by the ranges and the overall volt-ampere load. If you are unsure about any aspect of the volt-ampere load calculation, it is always best to consult a qualified electrician or electrical engineer. They can assess the specific situation and provide accurate calculations and recommendations. Also, consider the impact of harmonics. The electric ranges can generate harmonics, which are distortions in the voltage and current waveforms. These harmonics can increase the overall volt-ampere load and can also cause problems with other equipment connected to the electrical system. To mitigate the effects of harmonics, harmonic filters may be required. It is important to use the correct units when performing calculations. Kilowatts, kilovolt amperes, and amp should all be converted to the same base unit before performing any calculations. For example, kilowatts can be converted to volt-amperes by multiplying by 1000. When calculating the size of conductors and overcurrent protection devices for electric ranges, it is important to consider the ampacity of the conductors and the rating of the overcurrent protection devices. These values must be sufficient to carry the calculated volt-ampere load. Furthermore, it is important to verify that the electrical system has sufficient capacity to support the additional load of the electric ranges. This includes the service entrance, the panel board, and the branch circuits. If the electrical system is not adequate, it may need to be upgraded. The location of the electric ranges can also impact the volt-ampere load calculation. For example, If the ranges are located in a hot environment, the ampacity of the conductors may need to be derated. In addition to the electrical code requirements, there may be local regulations that also need to be considered. These regulations can vary depending on the jurisdiction and may include additional requirements for the installation and operation of electric ranges. Remember, safety is paramount when working with electricity. Always take appropriate precautions to avoid electrical shock and other hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following safe work practices. Lastly, documentation is crucial. Keep accurate records of all volt-ampere load calculations, conductor sizes, and overcurrent protection device ratings. This documentation will be helpful for future reference and for troubleshooting purposes. When dealing with multiple ranges, especially in commercial settings, it is often beneficial to use a load management system. A load management system can monitor and control the load on each range, preventing the total demand from exceeding the capacity of the electrical system. This can save energy and reduce the risk of overloading the system. In summary, calculating the volt-ampere load for electric ranges involves understanding the electrical code requirements, considering the power rating and quantity of the ranges, and taking into account various factors such as load factor, diversity factor, and harmonics. By following these guidelines and consulting with qualified professionals, you can ensure that the electrical system is safe and reliable. Always refer to the most recent version of the National Electrical Code, specifically Article 220.55, which provides the rules for calculating the demand load for electric ranges and cooking appliances. This section includes tables and notes that provide specific guidance for different scenarios. Additionally, Table 220.55 provides demand factors for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances of a 1.75 kilowatts rating. For example, column of Table 220.55 is used for ranges rated not over 12 kilowatts. The demand factor is based on the number of ranges. Column B applies to ranges between 12 kilowatts and 27 kilowatts, and column C is used when the individual range ratings exceed 27 kilowatts. Note 4 further clarifies that the over 1.75 kilowatt rating applies to other cooking appliances. Note 1 indicates that the table also applies to household cooking appliances rated over 1.75 kilowatts and used in instructional programs. It is essential to consult the specific notes in Table 220.55 because they provide crucial details that affect the calculation. Moreover, be sure to consider any local amendments or requirements that may supersede or supplement the NEC. The authority having jurisdiction, OJ, has the final say on the interpretation and application of the electrical code in a specific area. The calculation process also involves determining the nameplate rating of each range. The nameplate rating indicates the maximum power consumption of the appliance under normal operating conditions. It's usually expressed in kilowatts or volt-amperes. If the nameplate rating is in volt-amperes, you can convert it to kilowatts by dividing by 1000 and assuming a power factor of 1 for simplicity. In commercial installations where multiple ranges are used, consider the voltage balance across the three phases. Uneven loading across the phases can lead to voltage imbalances, which can negatively affect the performance and lifespan of electrical equipment. Distribute the range loads as evenly as possible across the phases to minimize voltage imbalances. Also, ensure proper grounding of the electric ranges. Grounding provides a low impedance path for fault current, which helps to protect against electrical shock and equipment damage. Use appropriately sized grounding conductors and follow the grounding requirements outlined in the NEC, specifically Article 250. Consider the energy efficiency of the electric ranges. Energy-efficient ranges consume less power, which reduces the volt-ampere load on the electrical system. This can save energy and lower operating costs. Look for ranges that are certified by energy efficiency programs such as Energy Star. Furthermore, it's important to consider the future expansion of the electrical system. If you anticipate adding more electric ranges or other electrical loads in the future, plan for sufficient capacity in the electrical system to accommodate these future needs. This may involve installing larger service conductors, a larger panel board, or additional branch circuits. Regularly inspect and maintain the electric ranges and the electrical system. This includes checking for loose connections, damaged wiring, and other potential problems. Address any issues promptly to prevent electrical hazards and ensure reliable operation. Use appropriate wiring methods for the electric range circuits. The NEC specifies the types of wiring methods that are permitted for different applications. Common wiring methods for electric range circuits include non-metallic sheathed cable, armored cable, and electrical metallic tubing. Select the appropriate wiring method based on the specific installation conditions and the requirements of the NEC. In addition, consider the use of surge protection devices. Surge protection devices can protect electric ranges and other electrical equipment from damage caused by voltage surges. Install surge protection devices at the service entrance and at the branch circuits that feed the electric ranges. When calculating the demand load for electric ranges, remember to account for any other appliances that may be connected to the same circuit. The total load on the circuit must not exceed the ampacity of the circuit conductors or the rating of the overcurrent protection device. If you are using a generator to power the electric ranges, ensure that the generator has sufficient capacity to handle the volt-ampere load. The generator's output rating must be greater than the total demand load of the electric ranges and any other connected loads. Moreover, be aware of the potential for voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source. Excessive voltage drop can cause electric ranges to operate inefficiently and can even damage the equipment. To minimize voltage drop, use appropriately sized conductors and keep the circuit lengths as short as possible. If the electric ranges are located in a damp or wet environment, use appropriate enclosures and fittings that are rated for wet locations. This will help to protect the electrical components from moisture and prevent corrosion. The NEC specifies the requirements for enclosures and fittings in wet locations in Article 314. If the electric ranges are controlled by a programmable logic controller, PLC, or other control system, ensure that the control system is properly programmed and maintained. The control system should be designed to prevent overloading the electrical system and to protect against electrical hazards. Use appropriately sized overcurrent protection devices for the electric range circuits. The overcurrent protection device should be sized to protect the circuit conductors from overloads and short circuits. The NEC specifies the requirements for overcurrent protection in Article 240. If the electric ranges are connected to a separately derived system, such as a transformer or generator, ensure that the separately derived system is properly grounded. The grounding requirements for separately derived systems are specified in the NEC Article 250. In commercial kitchens, where multiple electric ranges are used, consider the ventilation requirements. Electric ranges can generate heat and fumes, which can create an uncomfortable and unhealthy work environment. Provide adequate ventilation to remove the heat and fumes and to maintain a comfortable and safe work environment. Additionally, consider the use of energy management systems. Energy management systems can monitor and control the energy consumption of electric ranges and other electrical equipment. This can help to reduce energy costs and improve the efficiency of the electrical system. Ensure all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it is important to have it done by professionals who are trained and experienced in electrical safety. Always obtain the necessary permits and inspections for electrical work. Permits and inspections ensure that the electrical work is performed in accordance with the electrical code and that it is safe and reliable. When replacing an electric range, be sure to disconnect the power to the circuit before beginning any work. This will help to prevent electrical shock. Also, check the existing wiring to ensure that it is in good condition and that it is properly sized for the new electric range. If the wiring is damaged or undersized, it should be replaced. If the electric range is equipped with a cord and plug, be sure to use a cord and plug that are rated for the voltage and current of the range. The cord and plug should also be in good condition. If the cord or plug is damaged, it should be replaced. Furthermore, before connecting the new electric range, check the voltage of the circuit to ensure that it matches the voltage of the range. Connecting a range to the wrong voltage can damage the range and can create a fire hazard. After connecting the new electric range, test it to ensure that it is working properly. Check all of the heating elements and controls to ensure that they are functioning correctly. Also, check for any signs of electrical problems, such as sparks or smoke. If you encounter any problems, disconnect the power to the circuit and consult with a qualified electrician. Moreover, be sure to read and follow the manufacturer's instructions for the electric range. The manufacturer's instructions provide important information about the installation, operation, and maintenance of the range. Keep the area around the electric range clean and free of debris. This will help to prevent fires and other accidents. Also, avoid using flammable materials near the electric range. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical shock. Supervise children when they are near electric ranges and other electrical appliances. Finally, have a plan in place in case of an electrical emergency. Know what to do if someone is experiencing an electrical shock or if there is an electrical fire. Keep emergency contact information readily available.